Yo, so panibagong problem ulit in hydraulics at para sa video na to ay mag-compute o mag-solve ulit tayo ng mga problems tungkol sa open channel. Sa mga di pa nakapanood ng video lecture ko tungkol sa open channel ay ilalagay ko yung link sa description sa baba. Tara! So ito yung problem. Problem number 4, a rectangular open channel is designed to convey 2,500 liters per second of water. The roughness coefficient, so given na dito yung N, of the material of the channel is 0.022 and to be laid in a slope of 0.0015. What should be the dimensions for the most efficient cross-section of the said rectangular channel? So, illustrate muna natin. So, meron daw rectangular open channel. So, yung rectangular open channel daw will convey water. Ngayon, given na dito yung N o yung roughness coefficient which is 0.022. Given na rin yung slope. No? So, yung slope, okay na yung kanyang form. At pwede na natin siyang gamitin directly sa ating formula. So, in this case, itong problem is still uniform, steady flow. At hindi magbabago yung slope ng channel bed dun sa slope ng energy grade. Ngayon, given na rin dito yung Q, okay, o yung flow rate as 2,500 liters per second. So, gawin natin, divide lang natin to sa 1,000 para makuha natin yung flow rate na in terms of cubic meter. So, that is 2.5 cubic meters per second. Ngayon, ano daw ba yung magiging dimensions daw no? Para dito sa ating channel. So, ito yung depth no, ng channel at ito yung base width so, in terms of B. So, what should be the dimensions for the most efficient cross-section of the said rectangular channel? So, nandito na yung keyword natin. Sundin natin daw yung concept about the most efficient cross-section. So, pag sinabi sa problem, yung term na MES or most efficient cross-section, gamitin natin yung concepts no, na ng most efficient cross-section na diniscuss natin doon sa mga previous videos. Also, pag sinabi din na optimum sections, no, same lang din yung tinutukoy doon, yung most efficient cross-section. So, for our solution, so, since given naman dito yung Q o yung flow rate, gamitin na din natin siya no, for our working equation. That is Q is equal to A times V. Since uniform steady flow nga, yung consideration natin, yung value ng V is equivalent to 1 over N or 2/3 S raised to 1/2. So, ginamitan natin yung Manning formula since pwede natin siyang i-directly substitute sa ating equation. So, ngayon, maliban dito, pwede tayong gumamit ng equations using the most efficient cross-section na concept. So, since rectangular to, sabi dun sa ating discussion, sa isang rectangular channel, yung base daw for a most efficient cross-section is equivalent to twice as the depth of the channel. Also, yung hydraulic radius R is equivalent to D over 2. So, paikutin natin yung ating mga equations dito sa ating given equations ngayon. So, ngayon for Q, given naman siya as 2.5 cubic meters per second. Sa A, pwede nating sabihin na yung A daw is base times depth ng channel, base times depth, times 1 over N. Yung R, pwede nating iset as D over 2 raised to 2/3 S raised to 1/2. Since yung N at saka yung S naman is given. Ngayon, so, since given na nga yung Q, okay na tayo dito sa Q. Given siya. Given yung N, given din yung S. Kung papansin nyo, itong dalawang to, B and D, ay hindi naman siya given. Kasi yun nga yung magiging unknown natin. So, para ma-compute, no, yung mga dimensions yan, ay kailangan mag-set lang tayo ng isang variable dito. At pipili lang tayo, no? Since meron pa tayong iba pang working equations na pwedeng gamitin. Ngayon, may given na dito ng value ng B. So, yung B daw is twice as D. So, kung ipa-plug in natin to dito sa ating working equation, magiging isa na lang yung unknown. So Q is equal to B times D. Since B is also equivalent to 2D, that is 2 times 2D times D is 2D squared times 1 over n D over 2 raised to 2/3 S raised to 1/2. Ayan. So, plug in na natin yung mga values. So, that is Q as 2.5 cubic meters per second is equal to 2 times D squared, which is yun yung unknown, multiplied to 1 over N, 1 over 0.022 times D. So, D is unknown over 2 raised to 2/3 S. So, ang S is 0.0015 raised to 1/2. So, yun. Since dalawa na lang yung, isa lang pala yung unknown na lang natin dito, which is D. Pwede na natin siyang input sa ating calculator at tingnan natin kung ano magiging value ng D. This is 2.5 equals 2. This is alpha x squared. So, maglagay na rin ako ng multiplication operation dito. Multiplied to 1 over n, that is 1 over 0.022 multiplied to x over 2. So, this is raised to 2/3, 2 over 3 multiplied to 0.0015 raised to 1/2. 1/2. Oops. Ayan. So, ngayon, since na-input na natin sa calcu, ayan, try nating mag-shift solve. Shift solve at mag-input tayo ng any positive number, no, for our initial guess. Sana naman positive value din. So, ito yung na-compute natin na value ng x. So, yung x ay yung depth. D is equal to 1.046 meters. No? So, ito yung na-compute natin na depth. So, since ito yung depth, di pa tayo natatapos dun. No? Kasi, isa lang yun na compute natin. So, compute rin din natin yung B. So, B is also equivalent to twice as the depth. So, equivalent din siya sa 2 times 1.046 meters. So, multiply natin to by 2. So, yun. Ito na yung value ng B o yung base width, no, for a most efficient cross-section of a rectangular channel. So, 2.092 meters. Oops. Naging black. So, ayan. Box ko na para maging official na. So, ayan. Na-compute na natin yung unknown. At yun lang para sa video na to. Sana may natutunan kayo at see you sa next video. Thank you so much.